Hey Patrick, I'm gonna be sealing myself in a jar with a bunch of plants, and I'm honestly not really sure how long I'm gonna be able to survive in there because I'm a botanist and I don't know that much about human biology, but then I thought, hey, you do, so what do you think my odds are? Could you let me know? I would really appreciate that.
What's up, everybody? My name is Patrick. If you're coming over from Kurtis's channel, hi, hello, nice to meet you. This is my channel. So when Kurtis told me about his idea, my first question was, all right, it sounds dangerous, but is he really in risk of dying? And the short answer is no. Well, I mean, it's kind of yes, but it's also no at the same time. Experiments like this have been performed before, so Kurtis at least had an idea of what to expect. Kurtis got monitors for all the important gases and decided on numbers for those gases that would get him to quit before his body was in any real harm. And he had the paramedic on site just in case. But, as you might expect, he was still pretty concerned about his oxygen and carbon dioxide situation, which ended up sealing the deal in the end. So in this video, we're going to go behind some of the human physiology at work in Kurtis's experiment. So if you've been a human for a while now, you know that if you stop breathing, bad things happen. You can cause permanent brain damage or death within just a few minutes. And if Kurtis had no air in his tent entirely, then he would have died in just a few minutes because every cell in your body, with a few exceptions, demands oxygen all the time. And outside of our theoretical box here, even if you were to experience just reduced levels of oxygen, even in normal atmosphere, like at, say, higher elevations, you can still experience hypoxia, or lack of oxygen. And if you get really low on oxygen, you'll look like a combination of sluggish and drunk. You'd be disoriented, potentially hallucinate, drop in and out of consciousness, and your heart rate will go either too high or too low, and you'll experience cyanosis. Your skin will turn blue. Unfortunately, the exact oxygen production of these plants was a big unforeseen and totally out of my area of expertise. But Kurtis was confident that they would pump out enough oxygen. Either way, we still changed up his breathing situation a lot. So how are we so confident that he wouldn't just suffocate right away? In your body, the only reason that air goes in or out is because of pressure. And there's this fundamental gas law that says that gas will always go from areas of high pressure to low pressure. So to get air into your lungs, we need to create a lower pressure inside your lungs than the ambient pressure outside of them. So when you breathe in, your diaphragm drops, which lowers the pressure in your lungs. Since the pressure outside your body hasn't changed, gas flows in. Then when you exhale, you increase the pressure on your lungs and gas flows out. But we weren't worried about whether Kurtis had air to breathe, we were worried about not enough oxygen and too much carbon dioxide. And that was tricky to predict because the plants were such an unknown. So instead, we just measured the end result. How much oxygen actually got delivered to Kurtis's body. Now, to check for this, Kurtis originally had a monitor that would measure the oxygen in the air he was breathing. And that's great, but there's a big string of mistakes that can happen from the time that air enters your face to the time it gets to your tissue. So I politely suggested that Kurtis buy a device called a pulse ox, a small electrical device that measures the oxygen saturation of your blood. Normal oxygen saturation is around 98%, with anything lower than 85% getting really worrisome, and death happening around 60%. Kurtis decided that his critical oxygen saturation would be 94% and he would eject for safety. Because, yeah, the oxygen in the tent is interesting, but the number on the pulse ox is the one that becomes life or death. But as you saw from Kurtis's videos, his pulse ox stayed in the high 90s the entire time, so oxygen wasn't an issue. Carbon dioxide was. So why weren't we concerned with carbon dioxide poisoning? Well, it was a real risk, but a design restriction kept it from being a real threat. In a normal inhalation, only about 0.04% of that air is carbon dioxide. And then, because our body metabolizes oxygen and puts out carbon dioxide as a byproduct, that number jumps up to about 3.8% of an exhalation. Now, if we breathe in a little more carbon dioxide for whatever reason, our bodies can develop a condition called hypercarbia, which, among other things, makes our blood more acidic. And luckily, our bodies can detect that. It responds by breathing deeper and faster breaths, increasing blood pressure and heart rate, plus our kidneys up the production of bicarbonate, a molecule that buffers the acidity from that carbon dioxide. But the body can only adjust to a point. If the CO2 in the air we breathe gets above 50,000 parts per million and we breathe it in for enough time, our body's compensation mechanisms can break down, which is when serious harm happens. And if that number gets up to about 100,000 parts per million, we start looking at death. These are rough numbers, by the way, and all the sources for these values can be found down in the description. Now, Kurtis's monitor topped out at 10,000 parts per million, so he aborted way before that 50,000 parts per million. But even at that lower value, he still felt kind of off and disoriented, so it was probably a good idea that he called it when he did. Either way, I'm glad he made it out safe and that his experiment was a success. That's it from me in this video. If you're new around here and you like learning about the human body, consider subscribing or checking out any of these other videos. And if you thought that this experiment was just Kurtis out of his mind, leave us some comments, like the video, all that stuff. Either way, have fun, be good. I'll see you next time.